Might not be. Well, maybe no. Maybe next week. Maybe next week. Okay. So just this first section, describe the x values where the function is not differentiable. So in the first one with an absolute value function, and this takes some just eventually getting used to, but where do you suppose the sharp corner points are going to happen? It's just kind of is getting used to the ways of absolute value functions, and not just plain ones, like plain ones where there's a quadratic involved. Take a guess. Yeah. Yeah, when x equals 3. I think he's right. I would also insert something else. Anybody else have a guess? Yeah. -3. So if we type this in and I show you what this graph looks like. Math, absolute value of x squared minus 9. An absolute value function but with a quadratic mixed in, a little bit tricky. It comes to a point at 2 different spots. Now you would never know what that graph looks like, but definitely, hopefully you're at a point where your intuition, just natural gut, tells you something weird happens at 3 and -3, right? Now, if that was your gut, and obviously if you didn't have a calculator to look at to see that it comes at a point at 3 and -3, you could use your gut to test what is f prime of 3. And with the alternate form of the derivative, that would be your limit as x approaches 3 of f of x minus f of 3, which would be 0, over x minus 3. Now, the minus 0 means nothing. And this is where it gets a little tricky, because do we ever multiply absolute values by absolute values? No. But could you believe me if I told you that the absolute value of 25 is equal to the absolute value of 5 times the absolute value of 5? So even though we've never actually fully done that, you can, at least with your gut again, think of x squared minus 9 as x minus 3 times x plus 3. And then over the x minus 3, this part would be a jump function. And because of that, it wouldn't exist, right? So does not exist because of that jump function. If we plugged in the -3, it's going to look virtually the same. The top is still going to be x squared minus 9 minus 0. The bottom, though, will be x minus -3, which will turn into an x plus 3. But by the same logic of factoring out that x squared minus 9 into x plus 3, x minus 3, all over x plus 3. Now here's the jump part, and that's your does not exist. So that would have a limit of does not exist. If you plugged in the -3 to the second part, it would be a limit of -6. Does not exist times -6 is still does not exist. So your slope at -3 doesn't exist, and your slope at +3 doesn't exist, and that is evidenced in the graph. Good? All right, a piecewise function kind of changes things a bit. So wherever this graph leaves off, we can calculate what the slope at 0 on this graph would have been. And then wherever this graph picks up, we're going to calculate the slope on this graph at 0. And if they're the same number, then we're good. Because if this one ends with a slope of 2 and this one starts with a slope of 2, then it is meshing into each other very nicely, right? If this one ends with a slope of 4 and this one starts with a slope of 2, that's a sudden and drastic change. That's going to be a sharp corner point on the graph. Do you follow that logic? Okay? So let's treat it as two separate functions. We're going to find the slope of this one. So starting with the x squared minus 4 piece, we're going to find f prime of 0 on that one, because this one ends at 0. So using the alternate form of the derivative, that'll be the limit as x approaches 0 for f of x minus f of 0 in this case would be what? If we're using the top piece, what's f of 0? Negative 4 all over x minus 0, which would give us the limit as x approaches 0 of x squared minus 4 plus 4, so that's just x squared over x. Direct evaluation is going to give us 0 over 0, but easily we can cancel an x to simplify. And so what is this limit as x approaches 0? Trista? 0. You're just direct evaluating here. So wherever this function piece leaves off had a slope of 0. And then this one, wherever it starts, so 4 minus x squared is what we're testing now, we're going to find the slope of that at 0. And using the alternate form, 4 minus x squared minus f of 0 will be 4 all over x minus 0 is going to give us the limit as x approaches 0. The 4 minus 4 will cancel. It'll be negative x squared over x, which again is indeterminate but can be canceled. And we just get negative x. And that has a limit of, when I plug in 0, I'm going to get 0. So the slope where we leave off with this one is the same as the slope we are starting with at this one, which is a good sign. Let me sketch this graph for you so that we can also talk about the other factor you have to think about. X squared minus 4 is a parabola that's been shifted down 4. Agreed? We only want to see that when we're less than or equal to 0. So that's this chunk of it. So can you all see how we're ending with a slope of 0? Pretty much because they're cutting us off at the vertex. The other one is a parabola that's been flipped upside down and shifted up 4. And we only want to see that side of it. And we can see that as you're coming at this point of 0 from the right, our slope is leaving off at 0 because it's cutting us off at the vertex. But is this differentiable? There's a slope coming in of 0 from the left and a slope coming in of 0 from the right. So is the slope of this function at 0, 0? Why or why not? Is the slope of this function at 0 equal to 0? Sarah, what do you think? Correct. So the graph itself lacks what? The graph itself is what at 0? Discontinuous. And if you're not continuous somewhere, you can't even talk about derivatives. So probably that should have been the first thing we checked, right? Okay? So even though it's ending with a slope of 0 and starting with a slope of 0, if this one, if I shifted it down so that this one ended where this one began, then I would be in good shape. Because it would have been continuous and the slope ending the one would have been the slope starting the other. That would have been really nice. But because it lacks continuity, we can't even talk about differentiability, so we probably wasted our time with that, other than the fact that now you see how it would be done. So let your first test be for continuity. And that might save you a lot of work checking on differentiability. Because without being continuous, there is no way we're going to be differentiable. Capiche? Okay. All right. Oh boy, what time we got here? 9:29. Ooh. Ooh. Oh, well, there's no back. I'll probably adjust your homework a little bit, but we'll get started anyway with our 5 minutes. Find the derivatives from the left and from the right at x equals 1, if they exist. Is the function differentiable at x equals 1? Now, if you blindly go into this without thinking about it, and you just want to find the derivative at 1, you could use the alternate form of the derivative. Yes? Okay. So if we were to do that, I'm not hopeful that anything good is going to come out of this, simply because they asked for the from the left, from the right, obviously for a reason, right? And given that this is a square root graph, I'm pretty sure it has an endpoint, and I'm guessing that 1 is the location of that endpoint. But let's just pretend we're not thinking and we just jump right into it. F prime of 1. So the limit as x approaches 1 of f of x minus f of 1 will be 0 all over x minus 1. The minus 0 means nothing. I try to evaluate this limit so that I can get my slope at 1, and I get 0 over 0. How might I manipulate this? Rationalize. And in the numerator, I have a binomial that's factorable into 1 plus x, 1 minus x. So I'll get rid of that. I do have something canceling, which is great news. 1 minus x and x minus 1 will cross out and leave a negative. And so now the limit as x approaches 1 of negative parentheses 1 plus x over the square root of 1 minus x squared. And I'm going to try to directly evaluate. If I plug in a 1, my numerator is negative 2. If I plug in a 1 in the denominator, it's 0. A number over 0 is better than 0 over 0, right? Because at least I can say that the answer is does not exist. The slope at 1 does not exist. We thought that might happen, right? Tomorrow we'll pick up here, and so we'll look a lot more in depth of how am I going to now decide, is it like looking at the limit as we approach 1 from the left versus from the right, because the slope will exist coming from at least one of those sides. Yes? So your homework is going to be, go ahead Morgan, you can start passing those out please. They're all together. It's all one big pile. Corrections due Friday, but on page 133, how about you do 71 through 78 all and call it a day. 71 to 78 all. And then Thursday we'll do Okay. And then I'll pull this out and we'll adjust tomorrow's homework to be the other half.